I'm Phil Adams, the System Safety and Security Manager for Balfour Beatty.
Israel Simons, Traction Power Manager for Balfour Beatty.
Okay, this is the TPS-2 substation for the Peninsula Joint Powers Board electrification project. This is one of two major substations that will be utilized to power the future EMUs in the 51-mile corridor. This particular station, we have the interface between the PG&E transmission line. That transmission line is 115,000 volts, and it's connected at the first portion of the substation to the PG&E switchgear. There's a control building at the beginning of the station which allows PG&E to monitor and to remotely control that input into the substation. Ultimately, the entire substation will be automated and non-manned. So, now as we enter the substation itself, you see we have two independent power supply systems. The right-hand substation, portion of the substation, will power the north track, and substation on the left will power the south track. They're completely equipment redundant, provide the same service. Both are connected to the PG&E 115 kV transmission line. As we walk through the substation, what appears to be a complex network of equipment is relatively simple and straightforward. This particular device here is the PG&E disconnect switch, which allows them to manually disconnect the 115 kV from the substation. The next device is a PG&E metering junction box, and that's analogous to the power meter in your home. And that's the device that PG&E will utilize to measure the amount of electrical power utilized by the future system. As we move on, we have additional devices that will be utilized by JPB to isolate the main transformer from the PG&E 115,000 volt line. And we have a number of different isolation techniques for either for operational convenience or for maintenance. Now, this is the main step-down transformer, and what this device does is to step down 115,000 volts to 25,000 volts. The transformer itself is mounted on a containment device that in the event that the coolant oil within the transformer is compromised and drains out, it would drain out into this containment device, and in the event of a fire, it would limit the fire to this particular location. The concrete wall is a blast wall. The blast wall is designed in the highly unusual event that the transformer blows up or explodes, and the shrapnel from the transformer would not go over and strike the other power system. Moving on, you can see now this is the 25 kV disconnect switches coming from the step-down transformer. These switches or breakers will be automatically controlled either from the control building or in the future remotely from the JPB Power Control Center. The 25 kV circuit is then taken underground, goes up the gantry, and into the control building. Now, the purpose of the control building is to provide the access to manually control the entire substation locally, or the interface with the Power Control Center at JPB. The SCADA equipment is also located in that control building. And the electrical connection between the SCADA system and the breakers allows for remote operation of the substation.
The cables you see outside, they come in here, and they come in and because if you look at that, This is one circuit. This is another circuit over there, totally independent circuits.
Understood.
And then the cables you saw outside, they'll come over here and they come over there. And this distribute the power accordingly. So if I get power coming in here, and then I can actually, those breakers here, each one is a circuit breaker. So it will, if I energize that breaker, we transfer power to the track, whatever track you need to go. So there's really 4 tracks. There's the track 1 north, track 1 south, and the track 2 north and south. And here we have another one with a drill track, with a separate 3rd track. So we have all the breakers, each one for each one of them.
We can energize or de-energize either side of the substation, or we can energize or de-energize the power circuits that you see on the gantry in the back of the control building. That tall structure is utilized to transfer the electrified circuits from the substation to the OCS system across the tracks. Control building is utilized, as I said earlier, to provide pinpoint control of the power circuits. We can operate TPS2 locally, or it can be remotely operated. There are a number of different communication systems within this building which are connected to our SCADA system, which is connected to our JPB Power Control Center. In the event of a fire or heat, there is a fire suppression system in the building which will allow the fires to be extinguished without providing any potential danger to an individual who may inadvertently be caught in the building. So the gas does not deplete the oxygen, it simply lowers the kindling temperature of whatever is burning, and that extinguishes the fire. So that in a nutshell is the operation of TPS2 and how it's currently being planned for control.